Hello and welcome guys to this presentation on bridge engineering. Today we are going to talk about classification and types of bridges, also the components, key design concepts such as economical span, afflux, high flood levels, scour depth, loads on bridges, and IRC load specification and notable bridge failures in India. This is me, Kaustubh Hemachandra Kointe from MIT Academy of Engineering. So bridges are classified on various factors such as material, structure, usage, and span viability. First classification by materials classifies it into timber, masonry, steel, RCC, pre-stressed concrete, and composite. By structure, it can be classified by arch, beams, truss, suspension, cable stayed, and cantilever. By usage, we can classify it as road, railway, pedestrian, and aqueduct. By span and movability, short, which is lesser than 30 meters, medium, between 30 to 100 meters, long, greater than 100 meters, fixed, movable. So we are going to discuss on the types of bridges according to structure. First, there are arch bridges. In this bridge, the load is transmitted via curved structure. A prime example of it is Lisbon Aqueduct. Second is truss bridges. It consists of triangular framework. A good example of it is the Howrah Bridge. Third, cable stayed bridges. Cables connected towers to deck. The Bandra Worli Sea Link is a good example. Beam bridges. Simple, supported by piers. General flyovers. Then we have suspension bridges. Cable support deck. The famous Golden Gate Bridge is a prime example of it. Cantilever bridges. Balance arm for piers. Quebec Bridge. This is a figure of all the types of bridges. Arch bridge, tied arch bridge, cantilever bridge, truss bridge, beam bridge, suspension bridge, and cable stayed. Let us discuss the components of bridge. They are first divided into three main categories: superstructure, substructure, and ancillary components. In the superstructure, we have deck, girders, and bearings. It has the prime function of carrying the traffic load. Then we have the substructure. It consists of the piers, abutments, and foundation. This is responsible for transferring the load to the ground. Other than that, we have ancillary components such as railings, expansion joint, and drainage systems. These components ensure safety and maintenance of the bridge. Let's talk about the economical span concept. So, what is the economical span? Economical span is a span that minimizes total cost of a bridge, making it more feasible. What are the factors that affect it? Factors such as material cost, construction techniques, and site conditions. For example, river which span 50-60 meters are economical. Now we are going to talk about the hydraulic effect that act on a bridge, that are Afflux and high flood. So Afflux, water level rises upstream due to obstruction by piers or abutments, often increasing velocity downstream. Can be mitigated by designing wide spans and streamlined piers. Highest flood level. The maximum water level during the worst possible flood sets the minimum take height. Take level is maintained above HFL by 1-2 meters freeboard. Good example is the Ganga River HFL, that is 125 MSL. Next, scour depth and loads and bridges. Scour depth. Scour depth. It is the erosion around piers and abutments. It is influenced by factors such as velocity, sediments, and pier shape. To prevent it, we can design foundation deeper than max scour depth. For protection, we can use riprap, gabions, and deep foundations. So, what are the loads that act on the bridge? We have loads such as dead loads, live loads, environmental loads, and other loads. In dead loads, we have self-weight of the bridge. In live loads, we have traffic and pedestrian movement. In environmental load, we have wind forces, seismic forces, and temperature stresses. Other loads include impact, braking forces, and water flow. So let us talk about what IRC has given specifications regarding the bridges and also the bridge failures that have occurred in it. So IRC load classes, we have class AA, which is tracked vehicles 70 tons capacity. Class A, wheeled vehicles 55 tons. Class B, lighter vehicles. Impact factor is 10 to 25% of the live load. So let us talk about some notable failures in India. First is the Mumbai bridge collapse in 2022, which caused about 135 deaths. Second is the Mumbai flyover collapse in 2018, which resulted in 6 deaths. Third, Kolkata Majarhat bridge 2018, 3 deaths. The causes for this destruction and deaths is because of the poor maintenance, also overload, and most important part is the design flaws. In conclusion, what can we learn and what can we see forward in the future regarding bridges? So first of all, we need regular inspection of bridges, regardless whether they are new or old. Second, we need to adhere to the IRC standards. And third, we need to integrate technology into the bridges with real-time sensors to monitor the health of bridges. It can prevent damage, save lives, and build a nation. Thank you.